Okay, I guess that you've tried out the question and you're already waiting for the answer. Let's begin. So rough surface is inclined at tan inverse of 7 over 12 to the horizontal. A body of mass 15 kilograms lies on the surface and is pulled at a uniform speed, a distance of 75 centimeters up the surface by a force acting along the line of greatest slope. The coefficient of friction between the body and the surface is 1 over 7. Find the work done against gravity and then the work done against friction. Okay, to do this, all we need to do first of all is to draw a diagram, and we are having our incline, which is at an angle of tan inverse of 7 out of 12, and this is translated to 30.3 degrees. So if you have a body that has been moved up and that body is of mass 15 kilograms, that means that its weight is mg, which is the same as 15 times the acceleration due to gravity g. So at this point here, there is a normal reaction r. The body is moving up with an acceleration a, but remember that if the body is moving with a uniform speed means that the initial velocity v u is equal to the final velocity v, which implies that actually our acceleration will be equal to 0. That is at only maximum velocity. So our acceleration is equal to 0, and assuming that we have a driving force upwards, down the incline we shall be having the frictional force because they've talked about the friction, and then that is all I guess. And when we resolve the components of this weight mg, we shall end up with the component of the weight vertical to the plane, which is mg cos of theta. This is angle here is theta, and then the component of this along the incline downwards is mg sine of theta. So part A says that find the work done against gravity. Work done against gravity, by definition, work done is equal to force times the distance moved in the direction of the force. So in case you look at the gravity, work done by against gravity, the force is the gravitational force, which is mg, and the height that it has moved, or the distance, is in the vertical plane, that is the height h. So in case you remember that we've been given this distance here, 0.75 meters, that was 75 centimeters. Our angle was here, so this is our height h, and this is the same as 0.75 times sine of 30.3 degrees. So which means therefore implies that our work done will be equal to 15 times 9.81 times 0.75 sine of 30.3, which will give us 55.68 joules. That is the work done against gravity. Alternatively, we can do this. We can simply say that since we're talking about work done as the force times the distance moved in the direction of the force, assuming that the body is starting from here and it is ending up here, the distance that has been moved is 75 centimeters. And the component of the force of gravity is mg sine of theta. So we shall simply say that our work done is equal to the force times the distance, which is equal to mg sine of theta, then times the distance, which is 0.75, convert that into meters, and the answer will be the same, 55.68 joules. Then for part B, we shall simply say that our work done against the friction is equal to the frictional force times the distance moved by the frictional force. And according to our diagram, our frictional force is given by mu r times the distance d. And what is our r? Our r is this one here, and it is equal to the component of the weight vertical to the plane, which is equal to mg cos of theta. So we shall simply have r mu mg cos of theta, then times the distance moved, which is 0.75. From here to there, remember the friction is this, so it is moving from this point A up to this point B. So when we substitute on that, we shall simply end up with 1 out of 7 times 15 times 9.81 cos of 30.3 times the distance, which is 0.75, and the answer that we end up with is 13.6 joules. So that is the work done against friction, and this work is wasted. In other words, it will lead our effective work done to be not equal to 100%. But the question ends here. Enjoy.